Okay. So now first image may contain the several various kind of data. It may contains in a different multiple number of classes, and it is in a large count of memory. So now we cannot operate directly as a CSV file format or else a single file format. The data must be stored in a one drive. It must be stored in a one drive. But drive we are not uploading the corresponding the folder or collection of images we cannot collect by using the uploading option. There we are. After you click over the corresponding option, you have the two icons. One is a drive upload. One more is a direct uploading of a file. Now I think you had a practice in the last semester and before the semester you had a practice direct uploading of a CSV file. CSV file is a data which is it seems like feature extracted samples of a data set. Now that you can directly upload from this icon, but now my data is a very large amount of data. There we have thousands of images are there. We cannot upload as a single file. So now we should keep. You have to store the corresponding files into your drive, your Google Drive. Okay. So now you want to access the Google Drive. You just click over this icon immediately. It is asking about this code dynamically will generate. This code dynamically will generate whenever you click over the symbol. Means code is telling that can you include this drive memory into the Colab or your executing platform? It is asking. It is asking. So now you run this code. Which means that you are adding the drive memory into the Colab platform. Yes. Now it's successful. Actually, already I have included so that I got this information. But you will get a information like a successfully the drive is included to the Colab. Okay. Now after run this line, after these two, how I didn't write these two lines, Amma. Actually, whenever you click on this option, automatically which include. Okay, done. Now you open your drive. So this is my drive, nothing but that is your drive on your mail ID. Now open this drive and find out your corresponding image folders. There I have a folder one, folder two, glioma folder, non-tumor folder. Like that, these all folders are actually image files, image folders. If I open a no tumor folder, which has a several kind of images, so many samples are there under this one. Sorry. It's loading. It's loading. There are 1,000+ image samples are there. All they have to include into the our data. Now this is the first step, including of a drive memory to the your Colab. Next, next we should go to the uh, including the some directories or libraries we have to include. You know that normal libraries are like a NumPy, Pandas, Keras. These all are common libraries we should include. Along with that, we are interacting with the drive. Drive nothing but is a storage space. There the format of storing in the form of a file format. It must be operate with the one operating system. Means it is a drive operating system. It is a Google Drive operating system inbuilt which has. So now we are interacting with such kind of file structures so that we must be including the OS like OS library. We must be including the OS library. Then CV2 NumPy train test PLT matplot library. Okay, Seaborn library, all these libraries we should include. Okay, the next, along with that, actually we are running the neural network model, so that we must be include the we must include Uh, what are these one? Sequential. I will explain what you mean by sequential. What is a categorical? And in the part of Keras only we have a convolution 2D, some class is there, max pooling, flatten, dense, dropout, all we are including. Okay. Now, actually we want to add the driver data into the presently drive data into our platform. Okay. Now, to understand that, first we should know about including of adding the corresponding paths into the our drive. So here, how to add them? These two, I want to include the two or three classes that your wish. There I have a multiple number of classes are there. Folder one, folder two, glioma, some meningonia, and no tumor. These are the image classes. Image classes whichever I have actually downloaded from the Kaggle and I uploaded to the my drive. So you want to add. How many you want to add? You want to add two classes, three classes. That is your wish. Okay, na? So I'm removing this. Actually, I already executed this project. I'm removing these two addresses. Let me add now. Now, first one is a malignant path, normal path. Malignant path, nothing but something infected path. Next one is a normal path, regular and healthy path, healthy image set. These are unhealthy image set. I'm not going with the multiple number of classes in the first project. Later we'll go to the multiple number of classes. Now I'm going with a single class. Nothing but single, nothing but one is a malignant path, one more is a normal path. So no tumor is a it's a healthy path, healthy image set. Now I just want to copy that path and copy and paste over here. Just copy the path, paste over. It's same like you are adding the CSV file to the our Google Colab in same way. Here we are adding, but data is collecting from Drive. That is only the different. So again, I am copy this path. Okay. Now, to run neural network process, we must be include the operating system and OpenCV because we are accessing the data from our drive and running the application related to neural network. So OpenCV also important. This is all the library we should remember. Okay. Then followed by after this we want to find out what is the image size you want to apply because image size is also very important and how many epochs you want to run, how many cycles you want to run for the execution, and what is your batch size. I will tell you what I mean by the batch size. These are the common three parameters we must be include. Okay, so here the meaning of image size. Image size is the resize the image to the 128 to the 120. A small technique. It is a small technique for the processing. Normally whenever you capture the image from your mobile or any raw data from cameras, they need a large pre-processing steps because they are raw data, but this data set already prepared. I have downloaded from the Kaggle and is a well prepared data set, so that normally I'm applying that image size should be a 128 by 128 input size. Number of epochs I want, let's run for only 3 epochs because it takes so much of time. Next one is a batch size. Batch size nothing but there are thousands of apples are there in front of you in a basket. In every iteration, how many apples you can hold from your hand? How many apples? By using my two hands, every time I can able to access 12 apples. That is my batch size. My hands, whenever I want to transport to the one more container, in one container there are thousands of apples are there. I am collecting from my hand. So you are collecting from your hand. Na? So what is your hand holding capacity? It's a size of 12 for every iteration. So you can enable to hold the 12 apples and transfer to the one more container. Similar way batch size, how many samples can able to operate at once? That is about the batch size. Normally we are allocating this 32. So based on the accuracy and execution results, we can change the batch size. Okay. Now next load the load the data into data from drive to from where we want to drive to our platform, our Colab platform. So because all folders mathematics is a concept under operating system. So from there you are accessing. So stored memory. For that, we need these lines are common. So what actually we should do? We are creating one function. The function is name is a load images from folder. Folders are from where? In your drive. They are folder 2, folder 3, glioma, no tumor, all are folders. From there you are collecting. So your parameters of this function is a folder and respective labels. Label nothing but is a malignant path, normal path. Like that we have a labels. Label nothing but normally we should convert into 0, comma 1 because there are only two classes are there. It's a binary classification. Later, obviously, it can be convert. Then initially we creating a image list. So these are the lines under this function. This is one function. This is one function. Under this function, these are the lines. What are the lines? Image list is there for every file name. in OS, because OS is it's a library, it's a class. From there, we are executing the list dir, because the folder should be open in a directory format. And also, we are finding the path for every image, not for one image. After I open a one folder, there are 1,000 images are there. We need to access one by one. One by one, we need to access. So OS path join with in that folder with file name. One by one, we'll be able to access. Okay. Now image path will be identified. From there, we are accessing the image. So for that, we should use these lines. These are the lines commonly we should remember, because these lines are used to access your data images. Okay, see, image ready. I am ready and image ready. Image path. Open CV2. Um, Image ready. Grayscale, because we are operating with grayscale. Your images may be a colored image, but now we are not processing the colored image. We are processing with a grayscale. Means it seems like a black and white image. Okay. If image is not none, image is not none. Now process the image size, because what is the image size you prepared? 128 pre-processing. So make it is a pre 128, and append with every time after you process the image, append with a label. Like that, this is a complete pre-processing of your images. It means you have opened a folder, you download it from the folder, and you are accessing the image and keeping a proper size. This is a complete, it's not a classification, it's a general pre-processing stage. Then after pre-processing, load them into the our code now. Load all images into our code with a proper labeling. You give a proper labeling, because we are classifying with only two classes. Whenever you processing with two classes, nothing but is a true or false, yes or no, 0, comma 1. They all are binary classification. So now give a proper labeling for them. Now malignant part is a 1. If there is a tumor, it is a 1. If there is no tumor, it is a 0. Like that, you have to give a labeling. Normally, all machine learning algorithms and OpenCV supporting for the labeling of any data set, it must be start from 0 onwards. Okay, so 0, 1, 2, 3, like that we should give. So the data list will get appended with, uh, all images from the malignant path, all images from the normal path. So these are the line. Now the code, now the images are included to the our code. After including, we should shuffle the data, because data should not be in a sequence format, because we are training the image, we are training the model with a data. It should not be always, your first class should not be a AML. We should not prepare the timetable in such a way. If every day the first class is AML, you can remember the next day. If you don't want to come to the AML, you basically you can tell that. So obviously first class is to AML, and you get idea about. Means I want to tell you one more example. You are going to shop every day, and usually you want to purchase every day one chocolate. After 100 days, after 100 or 150 days, the shopkeeper will, whenever you come and you don't talk anything, he will just hand over the one chocolate to you. It's nothing but a fully trained process. In same way, in the same way, we should labeling 0, comma 1. A proper training should be created, so that we are shuffling the data elements. Not, no, we should not keep the data in a same sequence order. If you show a items to a particular newborn baby, so you are showing first one is a banana, second one sapota, third one is a pineapple, sapota, banana, sapota, pineapple, banana, sapota, pineapple. If you show in such a sequence for every day, she is expecting banana is a first item, second one is a sapota. Like that, she is expecting the same sequence. It's not a proper learning, so that we are performing the safely. It's not a proper randomly we should show, and even though the candidate, the corresponding person should be recognize the items, so that we are shuffling. Next one is a split features and split these features. Obviously, this full line you know very well from the beginning of your normal even machine learning projects. These lines are common. Splitting the data into training and testing, defining, identifying the target variable. These are the common. Okay. Now we are performing the classification of classifying of a two number of classes, so that we are including from all data elements for x and y, and x is equal, but normalize the pixels for it's actually images are performed, images are classified based on the pixel values. Every pixel has some binary code. Means gray code contains 8-bit of data, something like 8-bit of data. 8-bit nothing but what is the how many different values we can generate? We can generate 256 values. It's a process. 50 different kind of values will be generated. Means whenever is a complete all they are 0000 means it is a black color. Or if the pixel value is a complete all ones are there, it is a white color. The any value is some combination of 0 comma 1 comma 1, it means a gray coined, a light gray, something like thick gray, like that color will be fade from white to black color. There are so many variations we can see. So total variations are 256. Black to white, whenever anything is a transforming, how many variations we can set? 256 variations we are seeing. So that we are normalizing the pixel value with 255.0, then print x, then followed by we must be convert everything into a one hot encoding label format. One hot, we should convert. What do you mean by the one hot? One hot means, so there is a one animal like a cat. One more animal is a dog. One more item is cat, dog, followed by a banana is there. Yes, we are creating some elements like elephant. Okay, there are three animals are there, and three animal classes they are. We have so many cat images, we have so many dog images, we have so many elephant images. Whenever I am showing you one image, actually that is a elephant image. Then other value should be 0, 0, 1. This is whenever the case of image is a elephant. Actually, my next image is a dog image. Then 0, 1, 0. Again, next image is a elephant itself. Now 0, 0, 1. Then after I have an image as a cat image. Then after 1, 0, 0 like that. This is a one hot representation of your data. Actually, you have provided data as a image format, but our machine will convert into a label format. So this is a way we can say is a one hot encoding label format. Okay. Now we are splitting the data into training and testing format. This I think no need to explain. All the time these line is a common. There is a one train split function is there. This function input parameters are our all values along with the target values and text ratio and random state. Random state means you can give 42, 48, whatever it is. It's a number. We should give a positive number. Based on this, this function will return some value. The return values are properly will divide to this predefined pandas variables. Okay. Y test, Y train, X test, X train. We should keep in a even though there is a shuffling in a corresponding variable sequence, the variable will allocate you with a proper value. Okay, X train can able to recognize, X test will be recognized. Always we are giving in the same syntax format. Okay, now after splitting, now we want to run the corresponding code with. Now we want to run this corresponding code by using which one we should run. Before going to be executing the corresponding model, we can also exposure the project with different kind of images. We can expose it. What is actually the data set has? What are the images are there? What are the format of the images? If you want to see, we have a normal code. This is no need to practice, but I am telling because whenever you're writing any research paper, it should be exposed with different kind of images and results so that so that I am presenting this code. Actually it's a dump code. No, it is not about to classification. It is only about to present the image. That's it. What are the images we have? Two classes are there. In the two classes, two images are there. Actually, it is getting error. Instead of that, let me delete. But you can see if you want to see the images in the images in that corresponding code. If you want to see corresponding classes, you can run this kind of code. If there are three classes, three images will be print. Four classes, four images will be print like that. Okay. Let me go to the classification directly. So now we are classifying by using a CNN model. We are classifying by using a CNN model. First, to prepare a model. Prepare a model. How the CNN model will be? How the CNN model? There are so here I could say the CNN model. First, we had to prepare the structure of a model. It has an input layer. First, in every CNN model, we can find the two parts. One is the feature extraction part, followed by one more is a dense layer part. There are two parts are there. So see, here we have a dense layer. It's a dense part, flatten. After immediately after flatten, we have a dense part. Dense is different. Actually, before that, I should explain about ANN model. Do you know about the ANN? Do you know my ANN idea on that? Do you have idea about ANN model?
No, sir.
Tomorrow I will explain. No worry, Amma. No worry. Tomorrow I will explain. Today, just I want to give a outlet of how we can able to create a convolution neural network model. This is meant it is a convolution neural network model. To classify the images, we need a convolution neural network model. Okay, normally ANN, random forest, these kind of the SPM, these kind of algorithms can able to process only on numerical data. We should give an input as a CSV format. Image classification we can also by doing SVM. Yes, we can do, but before transfer to the image classification, we must be extract the features into a features. First, we have to extract the feature from image. Extract the features of image. Okay, image. Now features are will be converted into numerical values. Value. Now these numerical values can able to classify by using SVM. But what is the input of SVM at last? Numerical values only. But what is your initial input? Image. So image can also classify by using the SVM, random forest, and KNN algorithm. Based every algorithm can able to classify. But only the thing for them, first we had to take the image data as an input and extract the features. And the extracted features will be converted to numerical values like a format. Means they are in a CSV file format, followed by we are running the machine learning algorithm. These are the basic step. I think you understand. Here also, here also.
Sir,
Ah,
sir, for the pre-trained model,
yes.
they will give the features first only. Will they give the features first only, or else we need
For
to extract
pre-trained models
features?
means what do you mean by your intention? Pre-trained model means
I mean, already trained models.
pre-trained models means VGG is something generally called as a pre-trained model. And also resonant also a pre-trained model. Pre-trained model something but defined, the structure already defined. This is a customized structure. It's not a pre-trained. Customized structure. We have prepared, we have created. Some models are there. The models are pre-trained nothing but they already prepared their corresponding structure and they are available from our libraries. We can import directly, we can include directly into our code. They are called as a pre-trained. For them also these steps are common. Inbuilt they have these
Oh,
steps.
yes, sir. But how we will use the data sets in our daily coding
Now I think I
purpose?
have already included the data set into the corresponding this code segment. ఈ code segment లో మీకు ఆల్రెడీ data set ని మనం attach చేసేసినాం. After attaching this, now I am going for the classification. Data set is ready. It is attached to our code. Now we are going for the classification. Na? This corresponding convolution neural network will perform the classification, but there are steps you should understand how it is classifying. The steps you should understand. మీ డౌట్ ఏంటమ్మా ఎగ్జాక్ట్గా చెప్పండి వాట్ యు ఆర్ థింకింగ్.
సార్ యాక్చువల్ గా ఒక వీడియోలో చూసుండే ప్రీటెన్ మోడల్స్ ని ఎక్స్ట్రాక్ట్ చేయడం అవసరం ఉండదు అనేసి
ప్రీ
చెప్పారు,
ట్రైన్
అందుకే
ప్రీ
అడుగుతున్నా సార్.
ట్రైన్ మోడల్ కైనా కానీ ఇప్పుడు చెప్తానండి మీకు యాక్చువల్గా మీ కంటెంట్ నేను ఇప్పుడు కంప్లీట్ చేసినాక అర్థమవుతుంది. నేను ఇంతకుముందు మీకు ఏం చెప్పాను, ఈ ఫర్ ఎనీ మెషిన్ లెర్నింగ్ algorithm or any algorithm, if the input is image or if it is a sound or it is a any other format, should be converted into numerical format. Now image should be converted into which format? Numerical format. Means nothing but it's a
Numerical
SCSS
format.
format. After that we can able to perform the classification. Then only we can classification we can able to perform. For every algorithm it is a common. Now in CNN, inbuilt in this structure, we have a extracting of future feature stage, also classification stage. Both are included. That I am telling. There are two parts are there in CNN. The beginning part will extract the futures
Okay.
and they convert into numerical values. The values directly forward to the classification step. Inbuilt which has so that pre-trained models are no need to go for a such kind of feature extraction stage. And now this in this model also I
Oh,
am not extracting any feature. Na? In this model also I am not extracting any feature. Inbuilt which it has. Okay, ఇక్కడ కూడా నేను ఏం చేయట్లేదు. I'm not extracting any feature. Actually, if it is a SPM model, if it is a random forest, first we have to extract the features and generate the CSV file. Then after for uploading for the classification, that steps we need to follow. Here we no need to do. Inbuilt గానే స్ట్రక్చర్ లో ఉంటది. ఓకేనా? Now what is the initial
okay,
structure?
sir.
We are giving input to the first layer. Sequential nothing but it's a layer sequence. Actually, layer by input. There are input. If it is a 64 size, 64 images, something, and 64 neurons are there. 64 images we are collecting. After that, every neuron will create output. మీరు theory చూసారమ్మా? Do you read the theory about the neural network model?
Sir?
Do you know about the theory concept of a convolutional neural network model? Theory.
Yes, sir. Yes, sir, sir.
If there is a input with a some four neurons అనుకుందాం. Input is a four neurons. Now four neurons will get input of a one image. One image contains a multiple number of pixels. From every pixel, the input will be transferred. Now you imagine that your image will convert into pixel format. Pixel is a one binary code. థియరీ చూసుకోమన్నాను. మన ఇమేజ్ యువర్ ఇమేజ్
అర్థమైంది సార్.
your image is a binary code. Binary code have some metric value. After converting to numerical value, that will be a 24 of a one pixel. Some value will become a 127. One another pixel value will become a something like a 35. Like that, every pixel convert into some value. Do you understand? Based on the color. The color, it's a white
Yes, sir.
color. Then that pixel value is become a 255. If some pixel value is a 0, 0, 0, 0, 8 zeros are there, that value is become a 0. Like that, every pixel convert into some numerical value. Now these numerical values are will become input to the input layer. Input layer. If the input layer is created with some four neurons, example, there are four neurons are there. Now I think you understand the pixel values are converted into numbers. Now we are collecting four inputs to the one neuron. Like that, there are some 30 neurons are there. Example, 32 neurons are there. Every 32 neurons will access the for 3 by 3 matrix value, 3 by 3 corresponding image matrix value. And each neuron, 32 neurons are there. Na? There are four member deans are there, four deans are there. Every dean will interact with the faculty. If there is a dean of academics, should be disseminate the information to the all the faculties. Faculties are some 300 and the faculties are 300. How many deans are there? The neurons are three. Now three deans, every dean should pass the information to the 300 people. Now draw the structure, you will understand. 3 to 300. Now every 300 faculty should send the information to 10,000 students. 10,000 students. Every faculty, like that, see the structure. 3 to 300 to 10,000. Means each faculty should interact with the every student, like that I'm telling. Each faculty, each dean interact with the every faculty. Every faculty should interact with every student. But students are interacting with the, now it is like I think you understand. Student will write the exam and
Yes,
will,
sir.
uh,
Understand.
so like that multiple number of stages are creating. This is the first layer. This is the first layer. In a sequence, it is the first layer. First input has been taken. Our image is has taken with 128 by 128. Already we defined image size is 128, 128. Okay. So like that image size has been, image shape has been taken. Activation function is a ReLU activation function because ReLU activation function will process from 1 to infinity, because 1, 2, 3, 4, 5, 6, all the values will be included. Okay. So I think ఇవన్నీ యాక్టివేషన్ ఫంక్షన్ కూడా మీకు ఐడియా ఉన్నాయి. ఇక్కడ యాక్టివేషన్ ఫంక్షన్ అది యూజ్ చేసాం. దీంట్లో వెయిట్ యాడ్ అవుతుంది. మీరు ఒకసారి థియరీ చూడండి. టుమారో నేను మళ్ళీ ఒకసారి ట్రై చేస్తాను మీకు థియరీ ఎక్స్ప్లెయిన్ చేయడానికి. దెన్ ఫాలోడ్ బై మ్యాక్స్ పూలింగ్. ఎందుకంటే మ్యాక్స్ పూలింగ్ ఏం చేస్తున్నామంటే, ఇఫ్ ఇట్ ఇస్ అ డైమెన్షన్ ఇస్ అ 3/3, I want to reduce into 2/2. I want to get reduced. There are 8 people came into my chamber. I'm sure I just to assign the work. Sorry, ఒక పని చెప్తా. There are ఒక 5 members, ఒక స్టూడెంట్ వచ్చారు అనుకోండి. I have assigned the 8 assignments. 8 assignments ఇచ్చాను నేను తనకి. తను ఏం చేసిందంటే, he analyzed the assignments. He reduced the assignment to the 4. Sir, 8 అవసరం లేదు సార్. For this problem, you can convert the 8 problems into 4 problems. He has reduced the dimension of my assignments. Like that, max pooling will reduce the dimension of the neurons, because E to 300 means it is a large count. Large count of communication will be created. Somewhere we need to drop the dimension, like the max pooling, max pooling, min pooling, and average pooling. Like that, we have a by dimension reduction functions are there. Followed by again one more next layer is a 64 neuron layer. Activation function ReLU. Max pooling is same 2/2. Like that, we are extracting the values from each and every pixel. We are extracting. This will be run for multiple number of times for everyone sequentially. In these 3 layers, sequentially every process will be done. Immediately, we are applying some pattern operation that you read theoretically. Tomorrow, I will explain the theory, actual the structure. మీరు ఈ గ్యాప్లో చదివారనుకున్నాను, బట్ మళ్ళీ ఒకసారి ఎక్స్ప్లెయిన్ చేస్తాను. ఫ్లాటెన్ చేయాలి కంపల్సరీ. Immediately, we need to go for classification. Now, dense layers are used to perform the classification now. Up here, we have extracted the values from image. Followed by now, we are classifying this. The structure of creating structure is very important. Dropout means out of 300 faculty, everyone may not be provide the proper data. We are dropout. We are leaving some neuron values. We are leaving some neuron values because 300 faculty data need students under this because some faculty will convey the proper information. Some faculty will not convey the proper information. So we should leave some neuron values. So minimum dropout is there out of 300. We can imagine 300 people proper information is there guarantee unda? No. So we can say it is a dropout ratio is a 0.5. It's a minimal dropout. Neurons మనం డ్రాప్ అవుట్ చేసేస్తాం. దెన్ ఆఫ్టర్ డెన్స్ లేయర్ ఫస్ట్ వన్ ఈజ్ ఏ యాక్టివేట్ చేసేసి దెన్ ఆఫ్టర్ వీఆర్ యాక్టివేటింగ్ విత్ సాఫ్ట్ మ్యాక్స్. Okay, so this is a basic creating of structure for CNN. So you should understand these 3 layers are for convolution layers are for to extract the features, and followed by we have a classification segment of the same. These all they are in a single model. All they are in a sequential function under a model variable. Now model is ready. This is a structure creating for model. After modeling that, you compile the model. Now you run the model. Now model is a variable, it's created. Now you run the model. The model dot compile. Optimizer, ADAM optimizer we are using. And last function is the categorical entropy. Metrics is a accuracy. Okay, you run this model. I'm running for only 3 epochs. Somewhere there is a input shape. No, sequential is not defined. Some we are not defined. If you miss any library, something you cannot run the code. ఈజీ క్లియర్ అమ్మా. ఒక అవుట్లెట్ వచ్చిందా మీకు అర్థమైందా ఇది? ఈ ప్రాజెక్ట్ ఒకసారి మీరు చేయండి అమ్మా. నేను ఈ ఫైల్ కూడా మీకు IPYMB ఫైల్ షేర్ చేస్తాను. యూ కెన్ డౌన్లోడ్ డిఫరెంట్ అదర్ డేటా సెట్ ఫ్రమ్ ద క్యాగిల్ అండ్ యూ ట్రై దిస్ కోడ్. And followed by you can define your own structure for CNN. But before to create a CNN model, you should understand about the theoretical concept of a CNN. Otherwise, you cannot create properly. Why? What is the need of dropout? What is the need of flatten? Why only we are using softmax? Why we are only using ReLU activation function? For binary classification, we can use a ADAM optimizer. ReLU is for non-binary classifications. But here we are using ReLU can also use for binary classifier and other classifier also. ADAM for only binary classification. There are several reasons are there how the code is running. So after now model is fixed, model completed. Then we want to run the code. Means it is just train the model followed by train the model. We are training the model. It is running for only 3 epochs. After train the model, we should perform the test operation. We should also perform the test operation. This is for test code. This code IPYMB file I will share to you. You once practice with another model. Okay. Also gain the knowledge theoretically from YouTube videos or any other. I will also explain tomorrow. Okay. I'm expecting that you take spend good time for the doing a project for 10 days, 15 days like that. Followed by prepare a proper documentation. I already tell you that after you complete the documentations I will make publish. Okay. On your name. It's okay. Good accuracy, 72. It may 80 plus accuracy we already gained from this model. 80 means it takes so much of time because all they are images. So that I reduced the epochs to the 3 only. Normally we take a lot of time. Okay. So after this, I don't want to continue the meeting. But tomorrow I will explain one another concept. Otherwise, you can personally ask about any doubts. You keep a message in my WhatsApp. Tomorrow I will point out all. I will explain.
Okay.
Okay.